Welcome back. Have you ever wondered what's actually happening behind the scenes when you chat with an AI? Today, we're peeling back the curtain on the technology reshaping our world, from the simplest algorithms to the complex models that seem almost human. For decades, scientists have dreamed of creating machines that can think, learn, and reason just like we do. This pursuit birthed the field of artificial intelligence, a field that has evolved from simple logic to the incredible systems we see today. To understand how we got to large language models like ChatGPT, we first need to look at the hierarchy. Artificial intelligence is the overarching umbrella, encompassing every system designed to mimic human intelligence in some way. In the early days, AI was mostly based on if-then logic. If this happens, then do that. It was powerful for math, but lacked the flexibility of true human-like learning. That's where machine learning changed everything. Machine learning, or ML, is a specialized subfield of AI. Unlike traditional systems where every rule is manually written by a programmer, ML enables computers to learn patterns directly from data. Think of it this way. In traditional coding, we give the computer a recipe. In machine learning, we give it thousands of finished dishes and let the algorithm figure out the ingredients and the process for itself. The real breakthrough with ML was the realization that more data is often better than better rules. Over time, as these algorithms process more information, they naturally get better at accuracy and decision-making. Building a reliable ML model isn't just about the math. It follows a rigorous life cycle. It always starts with a very clear definition of the problem you're trying to solve. What is the goal? Take your email inbox as an example. The problem is identifying which incoming messages are legitimate and which are spam. This specific goal guides every single step of the model's development. Once the goal is set, we move to data collection. To teach a computer to recognize spam, we need to feed it millions of examples of both spam and non-spam emails so it can see the differences. But real-world data is almost always messy, biased, or incomplete. That's why data cleaning is the most time-consuming part of the process, ensuring the model doesn't learn from bad information. Next is feature engineering. This is where we identify the specific patterns that matter, like the frequency of certain salesy words or the reputation of the sender's address. During this stage, we have to be incredibly careful to avoid a common trap called overfitting. This is one of the most critical challenges in all of machine learning. Overfitting happens when a model learns the training data too well, meaning it memorizes the noise rather than the patterns, failing to make accurate generalizations. The goal is generalization. A successful model must be able to handle raw, brand new data it has never seen before. We ensure this by testing the model on data that was kept separate during training. Once the data is ready, we select the best algorithm for the job. There are hundreds of choices, from simple linear models to the massive neural networks we'll talk about later. Now, the training begins. The algorithm analyzes the clean data, slowly finding the patterns and relationships that will allow it to make its own predictions. Next comes constant evaluation and tuning. We check the model's accuracy, adjust its internal parameters, and keep retraining it until its performance meets our high standards. After rigorous testing, the model is finally deployed. It's now live, processing real-world data in seconds, like your email service automatically filtering out a new type of spam. But the work doesn't stop at deployment. Ongoing monitoring is essential. As the world changes and new data emerges, the model's accuracy can dip, requiring a new round of training. The ML lifecycle is a continuous, iterative loop. This constant feedback and improvement is what keeps these systems reliable and effective over months and years of use. We've explored the foundations of AI and the engine that is machine learning. But this is just the beginning. In Part 2, we'll dive into the world of deep learning, large language models, and the future of intelligence. Make sure to subscribe so you don't miss the next chapter of this journey. Thanks for watching, and I'll see you in Part 2.